Okay, hi, good afternoon. So, all of you know, today we are going to start matrix formally. Can you see my screen now?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes,
Yes,
Okay.
sir.
sir.
So here you can see I have already written the term matrix, and
Yes, sir.
because I am going to give the definition and some special types I am going to discuss. So here already I have written down one matrix. So what do you see here? Those who don't know what is a matrix, so you see some numbers. Yes, there are some numbers that you can see. Here is one. Yes, so something like this. So four horizontal lines are there, and again here five vertical lines. Yes, so numbers are somehow arranged. Although there are some numbers, but not some arbitrary form. Like here I have -2, -1, 3. So they are not in random order. Okay, some particular order is maintained. Some arrangement is there. Okay, you can see the first five numbers 1, 2, 3, 4, 5 in one row. Then next five numbers in another row, and also they are vertically arranged. So when you call matrix, definitely there are numbers or other symbols maybe, but the numbers are well arranged. Got it? So there is some order of the number, and arrangement can be of different types. Suppose if I arrange all the numbers, so 1, 2, 3, 4, this way vertically, that is also arrangement. You can write them in circular form also. This you construct a circle, then you are 1, 2, 3, 4. These two you can write all the numbers if you want. Okay. So, but here what we do, here we are going to write the numbers in rectangular form. So what we mean by rectangle? All of you see that actually the number here, if you see, this one is a rectangle, isn't it?
Yes,
Yes,
sir.
this one is a rectangle. So if I ask you the length and breadth, in some sense you can say length and breadth is for 5 or 4. Yes, here is, we have 5 lines, and then here I have 4 lines. So these are our horizontal lines. We call them, what we say, it is row. Or here, if I specify, this one is row 1, this one is row 2, here row 3, and here row 4. Okay, these are all rows. So in this particular matrix, we have 4 different rows, and here similarly, all these are columns. Got it? So in this particular matrix, we have 4 rows and 5 columns. So if we have to define the matrix formally, what can I write? So matrix is some arrangement of numbers. Okay, there is some particular arrangement. What kind of arrangement? It is rectangular form, because there are 4, 5. It looks like actually rectangle. So let us define it formally. We can write here. Okay. So if I write what is matrix, the matrix is, as I said, it should be rectangular. So I have written array, not arrangement. What do you mean by array? Any of you? Any of you? What do you mean by array?
Arrangement of numbers, maybe, sir.
Okay, arrangement. But when you call array, array means some ordered arrangement, or you can say some beautiful arrangement or attractive arrangement. You can say. So it is arrangement, but this comparatively stronger term. It says beautiful arrangement. Okay. So we arrange them in a nice structure. So rectangular array means the structure is nice as well as it is in rectangular shape. And what we allow some numbers. I have written only numbers. So any kind of numbers are allowed, or function. Function means I can have something, suppose x square, x cube, or anything I can allow. Okay. And besides that, you see the numbers have been written inside here, the first bracket or round bracket. So we must enclose them within the bracket. So a matrix is a rectangular array of numbers. Rectangular array, you can see this one forms a rectangle. An array, nice arrangement is there. Okay, of numbers. Here you can see number, but I can have some functions also. And what you do here, let me write inside bracket, enclosed by a pair of brackets. Got it? So here that pair of brackets, I have used the first bracket or the round bracket, but instead of that, if I want, I can use the square bracket also. So sometimes square bracket is used, or sometimes we use the first bracket, the round bracket we use, but we rarely use this curly bracket. We don't use curly bracket for matrices. Okay. So now if I ask you to give examples, definitely you can write examples yourself. Yes. So if I write some number, suppose 5, suppose 2 by 3, because any numbers are possible. Suppose here pi, all of you know the symbol pi. Suppose 4 minus 7. So this one is also a matrix. Yes. So how many entries are there? Entries means the building block or the component. So here total 6 entries or 6 elements are there, and number of row you can see 2 rows and 3 columns. So we denote this by 2 by 3. 2 by 3 means 2 rows. The first one we denote the number of row, and second the number of columns. Okay, this one is a matrix having 2 rows and 3 columns. You can have some other matrix also. Yes, you write whatever you want, but if you write here, suppose 1, 2, 3, 4, 5, 6, 7, 8. This one is not a matrix. Got it? So if you join the line, suppose in this way, you don't get a matrix. So if this one is a matrix, so if I join this way, this is all these lines. So is this a rectangle? No. Got it? So only when if you join all the numbers this way, that is boundary numbers, then it should be rectangle. So only if I add another number here at this position, that will be a matrix. Otherwise, it is not. Got it? So
Yes, sir.
Yes, sir.
yes, sir. As I said, fractions is also allowed. Any other number, y or any real numbers are allowed. So you can have. So what this 2 by 3 term denotes? So as I said, here are 2 rows and 3 columns. So we denote it by 2 by 3 in that way. Okay. So let me write something here. So 2 and 3, these are called order. Or let us write. So matrix, you can see. We suppose if I have to denote this and italic form. So can you read it? Can you understand? So if a matrix here 2 rows and 3 columns, but if I take a general matrix having m rows and n columns, then we say that this particular matrix is m by n matrix. So here it is a 2 by 3 matrix. And what is the order, or we say dimension or size? So size or dimension is m by n, and m cross n you can say, but we will give it as m by n. So here this one is a 2 by 3 matrix, and here it is 4 by 5 matrix. If you want, I can write it here. Okay, somehow. So it is 4 cross 5. So I have to select this one suppose. So here 4 cross 5 matrix. Got it? So number of, so how many total elements will be there in m by n matrix? Can you say? If A is a matrix of order m by n, so how many entries or numbers or whatever it is, elements will be there in that matrix?
M into M.
M into
M
n.
into
So,
n.
so order is m by n. We read this way, or we write it m cross n, but number of elements will be n. So now if I ask you, suppose we have the numbers 1, 2, 3, of course 36. Got it? So if we have to arrange them in a rectangular form or with expression as matrix, so how many ways, different ways can you write 36 numbers? Can you say? What are the possible orders? One, you can have, suppose
6 rows, 6 columns.
Row, 3 columns. Then 6 by 6. Then any other possibility? Any other possibility?
So 12 into 3, 3 into 12.
Okay, 12 into 3. And give me right side by side. Okay. Any other possibility?
So 1 by
So
4
in
in 4 rows, 9.
4 into 9.
4 into 9.
9
Okay,
into
then
4.
9 into 4.
9 into
So
4.
do you see 4 into 9 and 9 into 4 are different? Do you see? 4 into 9 means there will be 4
Yes.
rows and 9 columns.
Yes, sir.
9 into 4 means 9
Yes,
rows and 4 columns. So, okay. Then anything more?
2 into
1
18.
into 36.
36 into
1 into 36.
2 into
Okay,
18.
fine.
yes,
2 into 18
Okay,
is also there.
Okay, so 36 into 1 and one of you said 2 into 18 and 18 into 36. Sorry, 18 into 2. Okay, enough or we have something more? No. These are the all possibilities. Yes? So among them,
Yes,
do you
sir.
see? Okay, is there any other? No. So what we mean here 1 by 36 is actually this one. If you write this list as a matrix this way, then this one is nothing but 1 by 36. Yes? 1 row and 36 column. You can write this way. This one is also a matrix. Because by definition, we have some number in rectangular form. Okay? So row, how many rows? 1. How many columns? 36. So this one is 1 by 36 matrix. So what about 36 cross 1? If I write them vertically. Yes? So if I write 1, 2, 3, 4, and so on, 5. So this will be, okay? This will be 36 cross
36 into 1.
Okay, there are 36 rows and 1 column. The first one denotes the number of rows, the second number of columns. Is it fine? Okay. Among
Yes, sir.
all others, this one is somehow special, different from others, isn't it? 12, 3, 12, 4, 9. So 136, 36, 1, they are comparatively different because this is only one particular row. This one is only one particular column. Yes. Another one, there is specialty about this one. Yes. Do you see why it is special? Why it is so?
So it is a square matrix.
Okay, it is square. So here what we have, number of rows and number of columns are exactly same. Yes. So this one is
Yes,
also special. So that's what we are going to discuss some special types of matrix. This one is special. This one is again special, and this one is also special. That is same number of same column. So we will define them. Before that, we formally define a matrix in general form. This one is the example. This one is the definition. Okay, but how a general matrix look like? This one is the example. So yeah, this is the definition. It will have some numbers in rectangular array form, but we have to formally define the structure of a matrix. Okay, so let us try to do that. Sorry, I'm not going to say anything. Okay, so just write general form. Okay. Matrix. Okay. No, it's not write everything in detail because we already have your notes. Okay. So general form. So what we expect the general form will be? Suppose I denote the matrix as A. Okay. Okay. I have to choose this particular one. Okay. So if the matrix is A, I denote the matrix to be A. Then, as I said, the numbers will be written inside either first bracket or the third bracket. Okay, so let me choose the first bracket. So whatever be the number or the symbol at this position, the first position, you can say it is the first position, this one is second, third, and so on. But if I ask you a random question, suppose this one, suppose 17 in this particular matrix, what is the position of this particular matrix? I can ask, suppose I ask 0, and there is only 2 zeros. Suppose this 0, what is the position of this 0 element? Can you say me? What is the
2 into
So
2
it is
1.
in 4 and second row.
Sorry, sir.
Okay.
2 4.
Okay.
2
Okay,
4.
you can say, okay, you can say in different ways. First, if we go on counting the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, then somehow you can say it is in a 9th position. Okay. Again, if you want to calculate this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, somewhere it is in 14th position. So it is confusing. So someone will look for rows first, then the second row, then position is different. If you view the columns first, then this position is different. So if I write the entry this way, this is 1, 2, 3, 4, 5, 6, it is confusing because two of you say the position to be different. Yes. So instead of that, what do we do? So this one is the entry first entry, if I say this one is the second entry, instead of that precisely you can say, suppose 0 here, this is in the second row because I have written here, this is in the second row and fourth column. Yes, do you see? So this particular 0 is in the second row and fourth column. You can write, or suppose in short I write, it is a twofold element. Got it? In the second row and in the fourth column. Okay. So if I write the entries in that form, suppose instead of writing A, B, C, write A, B, C, D, and so on. So it will be confusing. So let us stick to a single symbol, suppose E. And this one entry will be in the first row because this one is the first row and it will be also first column. Let me write it as 1, 1. First row and first column. First, here 1 it indicates the row and second one indicates the column. Next entry will be, it will be again in the first row
1, 2.
1, 2. That is in the second column. Fine. So if I write this way, what will have here? Now I have to specify how many rows or how many columns I will have. Suppose m cross n. In general, I am writing. So suppose the matrix has m rows and n columns. So what will be the entry here? Anyone?
1
A
n.
1 and n.
1 n.
One n.
Because it is in the first row and n column because there will be total n columns. Okay. Now if I write the second row, because it is second row, 2 will be there and it is the first column, so it is 2, 1. Okay. Then here it is
3, 2, 1.
Then here it is again 2n because this particular element will be in the second row and
A2.
n column. Okay. Now what about the last entry here? That is the last entry of the first row. Sorry, first column. So although it is in the first column, okay.
AN1.
M,
AN1.
M1.
not M. M1 because there are m rows. So this particular entry will be in the m row and column. You can see it is the first column. So it will be A M1. So what is the next element? It is A.
M2.
So if I go on writing, what is the last element? Last element
AMN.
Mn.
because okay, this is the entry lying in the mth row and nth column. So this is in n column m row. That means the element is denoted by A M N. Is it clear?
Yes, sir.
Yes, sir.
So
Yes,
this
sir.
understanding we will often use to denote a general matrix because we cannot write Y, A, B, C, 3, okay, so on. Because if the matrix is of size 100 by 100, even 1 crore by 1 crore, I can write it. I'll simply write m equal to 1 crore, n equal to something, whatever will be the number 2 crore, I can write it. So this is the general structure. So if I want to write it again in complex form, so let me write it A, suppose I is it. Because
Ij.
every number is this, okay, every number in this particular matrix has this form. A and as a suffix we have 2 and so some numbers. Okay, suppose the first one is I, the second one is Z. What is I here? Again, as I said, the matrix is of order m cross n. So what can be the value of I? Can you tell me? If I write this way in this matrix, what is the minimum or maximum value of I? Can you tell me? Any of you?
So minimum value is 1 and
1
maximum
into
value is
M1.
m.
Maximum is
Okay, minimum is 1. You can see wherever we have, because this particular matrix, you can see there are m rows. So whatever be the row, so it is minimum 1. So if I consider I, so it is minimum 1 and maximum m. Got it? So if I consider J, it is maximum n and minimum 1. Is it clear? So instead of writing
Yes,
this way,
sir.
you can write it more complex form Aij. So and this will be Aij. That is suppose this entry A12 because 1 is there and 2 is also there. Also. So all the entries I can write this way. And if I have to specify, this one is a matrix. A is a matrix. Okay. And what about Aij? So this one is entry or component. You can say so entry or you can say element. These are all elements of the matrix A. And Ij, you can see I and J are of this type. That is I lying within 1 and m and J lying within 1 and m. Clear?
Yes, sir.
Okay. So you can write
Yes,
this
sir.
way. So whatever be the matrix, in general, whenever we have to consider a matrix, I will write either this way or this way. And This one is more complex. It takes less time or less space. So I will consider this one. Okay. Now let us go for special matrices. Okay. So as I said, let's define it. Sorry. Okay, let us define some special matrices. Special, suppose, first consider row matrix or column matrix. So, what is a row matrix? So, a matrix having only one row. Got it? A matrix having only one row is called So, what do I mean by this? A matrix having one row. So, whenever I say one row, so one example, as I have said earlier, so one example you can say, suppose sorry, this is this one. So, I take this pen and only one row. So, suppose 5, then 6, 7, 10. This one is a matrix having only one row. Yes?
Yes, sir.
This one is a matrix, only one row. Number of column is not important here. We only bother about number of row. This one has only one row, so it is a row matrix. So, if I look at this structure, okay, that is A Ij element, matrix is capital A, and Ij varies from 1 to n and 1 to n. And order is n by n. So, what is a row matrix in this term? Suppose if I use symbol, this one is a symbolic representation of matrix, isn't it? Capital A represent the matrix, small ij represent the element of the matrix, and ij the position, denote the position, and n cross n denote the order. So, if I write in terms of symbol, this one is nothing but, can you say, it is
A 1 cross M or N,
Okay.
whatever you
That
can
is
write. 1 cross
okay,
anything.
but
A
can you write this
variable.
way? Can you write this way? M equal to 1.
Yes,
If
sir.
Yes,
M
sir.
is equal
Yes,
to
sir.
1,
Yes, sir.
that's enough. Whatever be the value of N, we need not bother. If M is equal to 1, then it is a row matrix. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Similarly, you can define column matrix. What is that? I'm not going
A
to
matrix
write.
having
Having
one
only one
column
column.
only.
Okay. Having only one. I think I can copy from here. Why should I write again and again? Isn't it? Okay, I can. So, a matrix having only one, so I should replace this row by
Column.
column. So, okay, fine. So, again, if you want, I can give an example. An example. So, you know, what kind of example it should be? Only one column. So, I can write 7 minus 6, 3. Okay. If I write this way, it is a column matrix. So, here I should correct it. Okay, it should be, it should be column, no? Okay, so if I write again in symbolic form, you know, this one is equivalent
Here
to
N will be equal to
M by
1.
N equal to 1.
Okay, so matrix is here, row matrix is of type 1 cross, here it is 4. Here it is 3 cross 1. Okay, so matrix will be of type here, row matrix is of type 1 cross some n, and column matrix is of type m cross 1. But if I simply say m is equal to 1, that is a row matrix. N equal to 1, it means a column matrix. Okay. Now, what we have, another one we discussed. What is that? Square matrix. So, from the name you can guess. So, a matrix equal number of
Having equal number of row and columns.
Row and column.
Number of rows and columns. Okay, so can you give an example? I think all of you can. So let me write one.
4 by 4.
Suppose 4 by 4. Okay, 4 by 4. Can you tell me the entries? So tell me some numbers, all of you. Any number? I'm going to write some numbers.
Sir, 1, 2, 3, 4, 5, 6. Sir.
1, 2, 3, 4, 5, 6, 7, 8. Okay, let me write this way. 9, 10,
9.
11, 12. So 4 by 4. I need another row. Yes? 13,
Yes, sir.
14, 15, 16. This one is okay. Even 6 is sufficient. This one is 4 by 4. So in symbolic notation, what I mean?
M equal to N.
So here M is equal to N. If M is equal to N, that is a square matrix. So I have given two different interpretations. So if you have to define, you can write this way. That is A equal Aij is a square matrix if M equal to N. You can write that way also. Or the column matrix if N equal to 1. You can write that way, or in language you can write this way. It's up to you. Okay. So let us define another special matrix. Another special matrix. Suppose I consider zero matrix. The name suggests something. Zero matrix, a matrix. What is it? Having
All elements are 0.
All elements.
All entries are
element,
0.
okay. You said element, okay, let me write elements, okay, it's up to you. All elements as 0. Okay, so it is a zero matrix. So should I give any example? Okay, I can. So suppose 0, 0, 0, 0. Yes. So now my question is necessarily zero matrix be a square matrix? Every
No,
zero
sir.
matrix?
No, sir. No, sir.
Because the definition says it is a matrix having all elements 0. So 0, 0, 0, 0, suppose 0, 0, 0. This one is also a zero matrix. Okay? So
Yes,
square
sir.
matrix need not be zero matrix, or zero matrix need not be square matrix. Now come to again symbolic notation. Can you write in terms of this matrix? So what is the condition here? Do you see? So only
Aij
when
equal to.
Aij equals 0.
equal to 0 for any ij. Do you know this particular symbol? For all.
Yes,
Instead
sir.
of this, you can write, if you don't know, it is for all. Instead of writing for all, I will choose this particular symbol. For all I and j. So whatever be the value of I, j, ranging from m to n, because order will be there. For all I and j, Aij will be 0. Because as I said here, Aij is the element. So in the definition I have written, all the elements are 0. So instead of element, you can replace Aij. Got it? And 0, 0. I am replacing the term 0 by the number 0. Got it? So on all elements, I am replacing this term all by for all this symbol. Got it?
Yes, sir.
Okay.
Yes, sir.
Now, okay, what we discussed: row matrix, column matrix, square matrix, zero matrix. Let us come to more such definition.
Identity matrix, sir.
Okay, you already know identity matrix. Okay, let us go for it. Before discussing identity matrix, let us define something else. I am going to discuss identity matrix, but for that, I am going to define diagonal matrix. Do you know diagonal matrix? So diagonal matrix means something. Okay, before discussing diagonal matrix, let me write what is a diagonal element. So if I have a matrix, suppose, okay, let me choose one. So this one is a square matrix. So square is there. So whenever I have a square, whatever is the shape, so there will be a diagonal. Do you see the diagonal here? Yes. This one is a diagonal. You got it?
Yes,
So
sir.
1, 2,
Yes, sir.
sorry, 1, 6, 11 and 6. These
16.
four constitute a, sorry, 6, no, actually I wrote 6, whatever it is, this one is a diagonal. Okay, but in case of other matrices, suppose in random matrix, suppose this one, we cannot directly talk about diagonal. If I say that 0, 0, this square diagonal, somehow they are true, but only in case of a square matrix, so diagonal makes sense. And this one is another diagonal, 4, 7, 10, 13. But what about the speciality of this diagonal? So you can see what is the position of this particular entry, 1, 1. Yes, this entry, if I say, yes, what is the position? It is 1, 1. Yes. What is the position of this entry? It is 2 2.
2 2.
2.
Yes. It is second row, second column. What about this? It is in third row, third column, 3 3.
3 3.
Okay. Again here it is 4 4. So all the elements for which the position, that is I and J both are same, we call them diagonal entries. Okay, I am not going to write it formally, but diagonal means this one, not this one. Although 4 is square, this one is also a diagonal, but here for this entry, what is the position? 1 4, not 1 1 or not 4 4. Okay, but for these diagonal entries, the position I, J both are same, 1 1 2 2 3 3 4 4. Got it? So whenever we have a square matrix, so we have a diagonal entry, means the entries. So now what we consider, if all the non-diagonal entries, that is only the diagonal entries are there, other than that all are 0. Suppose a diagonal matrix means a matrix, okay, let me specify square matrix. Okay, a square matrix having all of diagonal entry or non-diagonal entry, you can say non-diagonal entries or elements as 0. So we consider a square matrix, and what more we need? Okay, we need the non-diagonal entries should be all 0. So let us give an example again. Can you help me? Any of you? Okay, let us first consider 2 by 2. Suppose 1 0 0 2. Okay, a square matrix. This one is square, having all non-diagonal. This one is a diagonal entry, 1 1 position, 2 2 position. Other than that, all the non-diagonal entries are all 0. So this square 0. Okay. If I have to write a 3 by 3 matrix, because it should be square by definition, so 3 by 3 matrix, suppose 4, 5 minus 6, suppose, and all here, all are 0. Got it? Only in diagonal, but so if I consider this particular matrix as I considered earlier, is this a diagonal matrix?
Yes, sir.
Is this a diagonal? Yes, sir. Why?
Yes, sir.
Why?
No, sir.
Okay.
No,
Actually,
sir.
those who said no, I would like to know the reason. Why do you think that it is not a square matrix?
Sir, because in the definition it is mentioned that all non-diagonal and entries should be 0.
Yes, yes, fine. So in the definition, it is mentioned that all the non-diagonal entries are 0, isn't it? Here, all the non-diagonal entries are 0. So what's the problem?
Yes, sir.
Got it?
I am telling
So
this.
there, okay, there is no restriction about the diagonal entries. The definition says that all the non-diagonal entries should be 0. Got it? So by
Yes, sir.
definition, these two are also diagonal matrix. Okay, this one is 0 actually. I didn't write 6, so I give it to be 6. So restriction is on non-diagonal entries. So if non-diagonal entries are all 0, then it is 0 matrix. We don't have any restriction about the diagonal entry. This here diagonal is 0, no problem. Only you have to check whether all the off-diagonal entries are 0 or not. Is it clear?
Yes, sir.
Yes, sir.
Okay. So we don't have, like in row matrix or column matrix. Row matrix means only one row. We don't have any restriction about column. It can have infinitely many, 100, 1 crore column. We don't bother about it. So we'll check how many rows are there. If it is only one row, it's a row matrix. So if all the off-diagonal entries are 0, it is a diagonal matrix. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now symbolic. Symbol. So what was the okay for okay? So symbol was Aij. Yes, something like this, and it is n cross n. So what is the condition here? Because it is square matrix, you can see I have written it should be square matrix. The first condition is m should be equal to
Sir,
n. Okay.
for
Then,
every, yes, sir. Sir,
then
for every I is not equal to j, the element should be 0.
okay. So Aij equal to 0 for all I not equal to 0. Why it is so? What is the position here? The position is okay. Here position is 0 for this particular entry. Position is 1 2. Okay. For diagonal entries, as I said, positions are 1 1 2 2 3 3 or in short I. So for diagonal entries, Ij both are same. So of diagonal entry means all the numbers for which the I and the corresponding j are not same. So here it is 1 2. Here it is 1 3. So only for diagonal entries, I and j are same. So if I and j are not same, it means the off diagonal entry or non-diagonal entry. So off diagonal entries are 0. It means for I not equal to 0 or I not equal to j, a corresponding element, that is aij, should be 0. Any confusion?
No, sir.
All of you understood?
Yes, sir.
Yes, sir.
By definition, it should be square matrix. So by this, in symbol, we mean m is equal to n. And non-diagonal entry means I not equal to 0. That is the concept of non-diagonal entry. And 0, I am using 0. Got it? So this is the definition. Okay, if you have any confusion, you can ask. Otherwise, I am going to define another matrix. So I am going to define scalar matrix. What is that? That is also a diagonal matrix having all diagonal
Having same.
Okay, all diagonal entries equal. Or if you want to write that way, okay, a diagonal matrix having all diagonal entries equal. What's same? Equal, right? So, because it is a diagonal matrix, you know, we have to write something of that type. So, is this a scalar matrix? Is this one 0 matrix?
Yes, sir.
Yes, because what we have to say, is it diagonal or not? Diagonal means all the off diagonals should be 0. That is you have to say. Then all the diagonal entries should be same. Here all the diagonal entries are same. So that is also a scalar matrix. So if I write something other than that, so here suppose 3, 3 and 0, 0. And so this is a diagonal matrix. And again, as it is diagonal matrix, it should be square. And scalar means diagonal besides all the diagonal entries same. Here this one is diagonal matrix, but 4, 5, 6, these are different entries. So here it should be same. So again you can write 3 by 3 also. Okay. So whatever be
Yes, sir.
the number you choose, suppose choose -2, -2, -2. All other entries here, they should be 0 by definition. Okay. Also, you can write 0, 0, 0, 0 again, same as before. It is also a scalar matrix. Fine?
Yes, sir.
Okay. Now again, let us try to understand in terms of symbol. Because it is diagonal matrix, all these will happen. Yes, the condition of diagonal matrix will be satisfied. So m is equal to n. Then aij will be equal to 0 for all I not equal to 0. That will happen because it is also a diagonal matrix. But there is one more restriction. What is that? All the diagonal entries. I can write suppose ij, or you can say ii. Okay. I suppose, because I is equal to j, it is I equal to some k, some constant, or what is that? It is some constant, fixed number, and for all I entry, because this one is the entry 1 1 entry, this is 2 2 entry, 3 3 entry. Yes, for diagonal entries there should be a fixed constant number. Here it is constant is -2, here it is 3, here it is 0. Got it?
Yes, sir.
So, okay. So scalar matrix, if you have any confusion, you can ask. No confusion.
Yes, sir.
If you don't have any
Yes, sir.
question, then I am going to define identity matrix. As one of you suggested, identity matrix. Okay. There are some other names also, like zero matrix is also known as null matrix. Identity matrix is also known as image matrix. So here, a scalar matrix. Sorry, the matrix. All of whose diagonal entries are unity, or you can write one. Okay. So this one is, as I said, scalar matrix. So all the condition of scalar matrix will hold. So if I have to give example, so it should be scalar matrix. So all these things will happen. Definitely it will be square matrix, m equal to 1, m equal to n, and all the off diagonal entries should be 0. And there is another restriction. This k is 1. That's it. All these will be satisfied, but this k here, any constant is allowed, but in this case, identity matrix, only k can be 1. So here it is 1, 1, 0, 0. Okay. Suppose 3 by 3, 1, 1, 1. So other entries are all 0. Any question? In symbolic notation?
No, sir.
In symbolic notation, again, m is equal to m a I j. Because it is scalar, all these things will happen. I not equal to j. And here a I must be equal to 1. Not any constant. All the diagonal entries are equal. Any number, suppose 2, 3, 4. But here all diagonal entries are also fixed. It is 1. Here I did not write the term constant because it is already 1 for all. Okay. So from this you can see identity matrix must be a square matrix because here m is equal to m. So because it's math paper, if you prefer symbolic notation is better because it saves time and it looks better. M is equal to m a I j. But if you find it difficult, you can use this definition. But I have given both the definition. But this is the mathematical expression. This is the language. Any question, all of you?
No,
No,
sir.
sir.
No, sir.
All of you have understood? Okay. So this one is the identity matrix. So then let us go for a different matrix. Okay. Triangular matrix. So let us write triangular matrix or specify upper triangular matrix. There are two matrices. One is upper triangular, one is lower triangular. What is upper triangular matrices? A matrix. Okay, I have taken specify. It should be again square matrix. Square matrix. Square matrix with all the elements below the diagonal, or you can write main diagonal below the main diagonal. And because there is another diagonal, you can see in square matrix, but that we don't give any importance here. Okay, square matrix with all the elements below the main diagonal are 0.
0.
Okay. I don't know how many of you got the definition, but let me describe an example. So, first of all, the definition says it is a square matrix. Okay. So, okay, let us first write 2 by 2 matrix, square matrix. Then, with all the elements below the diagonal. So, there is a diagonal like this. Below them, it should be 0. Below this one, that is for the left. And here I can write any number, suppose -2, 3. And there is no restriction. I can write any number here. So, why it is upper triangular? Do you see this one? The diagonal with the upper entries looks like a triangle, upper triangular. So, if I consider a 3 by 3 matrix here, suppose 9, 7, 8, okay, this should be 0 because 10, -5, 6. These are the non-zero entries, but all this should be 0 because this one is the main diagonal, yes, and below this all should be 0. By definition, it should be a square matrix with all the elements below the main diagonal be 0. This one is the main diagonal 9, 10, 6. They construct they consist of the main diagonal, and below them all the entries should be 0. Got it?
Yes, sir.
Confusion? Okay.
Yes, sir.
But we don't have any restriction about diagonal entry. Sorry, diagonal or upper entry. So if suppose 7, instead of 7, if I write 0, that is again, got it? That is again a upper triangular matrix. So here you can see we have a triangular here, triangle. Yes. In the upside you have a triangle. Or here this is a triangle. Okay. So upper triangular means I will have a triangle of this type. Here this can be 0, 7 can be 0, we don't mind that one. But below them, below the diagonal, everything should be 0. Okay. So can you write in terms of symbol? Can you? So what is the condition? Because it is square matrix, again I need m is equal to n. What else do you need? Below the diagonal. So some elements should be 0. Let me write. Some elements should be 0. But can you specify for what kind of I and j it should be 0? Okay. Can you? Any of you? All ij not equal to 0. So here for all I or j. So for all ij, Aij is not 0. Some elements are 0 below the diagonal. Can you identify the position of below diagonal element? Any of you? Hello? No.
Sir, I greater than J.
Okay, I get that in. Okay, let me check. So what is the position here? So here position is 2 1. Yes? This one entry, if you say it is 2 1. Okay, here it is 3 1. This one is again 3 2. So you see, I is less than j. Yes? For diagonal entries, I and j are same 1 1 2 2 3 3. For this entry 1 2. For upper entries, these entries you can see j is greater, but for the entries here below the diagonal, I is greater than j. So got it? So here for all
Yes, sir.
I greater than j. Got it? Only when, so you can see all these entries 2 1 3 1 3 2, and here it is 2 1. So if I is greater than j, the entry should be 0. That is the restriction. Got it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So let me write again the lower triangular matrix. It is similar. I have copied it here. Okay. Copy paste. I can do that. Okay. So what I should replace? Upper should be replaced by lower. Square matrix with all the elements. It should be above. Yes.
Yes, sir.
Above the main diagonal. Okay. So I think you all understood what exactly lower triangular matrix is. So if I consider 2 by 2 matrix, 5, 7, all the matrix above that, it should be 0. I don't have any restriction here. Suppose I can write 2. Okay. So even if I consider another 2 by 2 matrix, suppose 9, 10, 0, 0. Isn't it a upper triangular matrix? Is this
Sir,
upper
yes,
triangular?
it is.
Yes.
Yes, sir.
Yes, sir.
So diagonal matrix are upper triangular as well as lower triangular. Got it? Because it is diagonal,
Yes, sir.
all the off diagonal entries are 0. So by definition, this one is upper triangular as well as lower triangular. So again, if you write the 3 by 3 matrix, you can write, so all the entries, suppose again, let me write 1, 2, 3. So it should be 0. All the entries above, this one is a diagonal entry. So whatever I have, this should be 0. And I can have any, suppose I have 0 here, I don't mind, 4. Some numbers can be 0 here also, but all the entries above the diagonal should be 0. Okay, is it clear?
Yes, sir.
So in
Yes, sir.
symbolic notation, you can see it is again square matrix, and what we have Aij equal to 0. I think all of you can guess what is the condition here. I is less than.
I
I
is
less
less than j.
Okay. So this position is 1 2. This one is 1 3. This one is 2 3. So on. So whenever I is less than j, the corresponding entries are all 0. Any question? Any of you?
No, sir.
No, sir.
No. Okay. So what we have discussed so far, what is a matrix? Some special types of matrix like diagonal matrix, square matrix, zero matrix, and okay, identity matrix. So do you see matrix in real life anywhere? Do you see there are matrices? Do you really need it? Any matrix structure?
Say in March 1st.
Okay. Now, any other example? Suppose in your agricultural, if you go for any crop, like your tree garden, rice crop, do you see the structure? Yes? Isn't it rectangular? Isn't this a matrix?
Yes, sir.
Sir,
Any of you? Yeah.
so while writing a matrix, we can use both curve bracket and square bracket, right?
Yes, we can. But not curly bracket. So here, if you want, you can write this way also. 1, 2, 3, 4. You can. But this one is not allowed because this one is actually reserved for some other operation like set. Okay, if you write some element inside this bracket, it will denote a set. So a first bracket or third bracket, round bracket or square bracket, you can use for matrix.
Okay, okay. Thank you, sir.
Okay. Any more question? No, no more questions. Okay, then I think we can stop here. So we'll see you in our next lecture. where we will discuss the basic operations of matrices like matrix addition, matrix subtraction, and all those. So, okay, thank you. See you in the next class.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.